let's just move on further towards the next topic of introduction to trigonometry, and which is nothing but trigonometric ratios of the complementary angle. So let's just discuss first that what are complementary angles. So if we are talking about the complementary angles, then any two particular angles are said to be complementary if their sum is equal to 90 degree. So let us suppose if we are talking about any particular right angle triangle which is right angled at B. So if in a right triangle it is right angled at B, it means that the sum of other two sides would be is equal to 90 degrees. So hence these two angles would be called as nothing but the complementary angles. So always remember, any two particular angles are said to be complementary if their sum is nothing but is equal to 90 degree. Now moving on further with the complementary angles, we will now discuss the trigonometric ratios of the complementary angle. So let us suppose if I am just talking about any particular right angle triangle. So let us suppose this is my right angle triangle. This is my right angle triangle such that it is right angled at B. So I have taken this particular right angle triangle and I am calling this particular side as nothing but A. I am just taking this side as nothing but C. So let us suppose first of all I am talking about this particular angle, that is angle A. So since we know that the trigonometric ratios for this particular angle A can be of the form, so let us suppose if I will write it over here, this would be nothing but sine of A. We know that sine of A is nothing but the side which is opposite to the angle A divided by the hypotenuse. So let us suppose this would be nothing but BC divided by AC. So sine A is actually BC divided by AC. Now let us suppose if I'll say what is cos of A. Cos of A is nothing but the side which is adjacent to the angle A divided by the hypotenuse, and that would be nothing but AB divided by AC. And similarly, if I'm just talking about tan of A, tan of A is nothing but again the side which is opposite to the angle A divided by the side adjacent to the angle A. So this would be nothing but BC divided by AB. And furthermore, if I'm just talking about the other trigonometric ratios, means the reciprocal of sine A, which is nothing but cosec of A. So cosec of A is nothing but AC divided by BC. I'm just taking a reciprocal of these. And further, secant of A is nothing but can be written as AC divided by AB. And further, we can write the tan of A, which is nothing but the reciprocal of tan is cotangent of A. We can write it as cot of A. So this would be nothing but AB divided by BC. AB divided by BC. Now let us suppose if I am just talking about the complementary angles. What are the complementary angles? If we are just talking about this particular triangle, that is ABC, we know that the angle B is definitely 90 degree. Angle B is definitely 90 degree over here. And further, we know that if angle B is 90 degree, then by the angle sum property of a triangle, angle A plus angle C would be equal to 90 degree. We know about this particular fact. By the angle sum property, if angle B is 90 degree, it means the sum of the other two angles would also be equal to 90 degree. Now let us suppose if I'm just talking about this particular angle C. So we know that angle C is actually nothing but is equal to 90 degree minus of angle of A. We can write this angle C in this particular manner. We can write this angle C in this particular manner. Now using this angle C, now I am going to find out all these trigonometric ratios one by one. So let us suppose now I am considering this angle C. So we know that if we are considering this angle C, then this would be the side opposite to the angle C divided by, and not divided by, this would be the side opposite to the angle C, and this would be the side which is adjacent to C. So let us suppose if I am just finding out all the trigonometric ratios which are related with the angle C. So let us suppose if I am starting with the sine of C. So we know that if we are talking about sine of C, then sine of C would be actually nothing but is equal to the side which is opposite to the angle C divided by the hypotenuse. So the side which is opposite to the angle C is actually AB. It is AB, and the hypotenuse is nothing but AC. So we can write sine of C as nothing but AB divided by AC. And furthermore, I can write the C angle as nothing but 90 minus of A. Why so? Because of this particular fact, we know that angle of C can be written as 90 minus angle of A. It means that we can further write this sine of C as nothing but sine of, in place of C we can write 90 minus of A, which is nothing but is equal to AB divided by AC. So we can definitely write this particular trigonometric ratio sin C as sin 90 minus of A because of this particular fact. So we can write sin 90 minus A, which is equal to AB by AC. Now in the similar manner, I'm going to find out the other trigonometric ratios for the angle C. So let us suppose if we are just finding out cos of 90 minus A. So let if we are finding out cos of 90 minus of A. So this would be cos of 90 minus of A. Means if we are talking about 90 minus A, we are actually talking about the angle C. So we are actually talking about this angle C. So let us suppose if I'll write it over here, this is nothing but 90 degree minus of angle of A. This is 90 minus angle of A. So again, if I'm just talking about cos 90 minus of A, means we are talking about cos of C. So cos of C is nothing but the side which is adjacent to the angle C divided by the hypotenuse. So this is BC divided by AC. So this is BC divided by AC. Furthermore, if I'm just talking about tan of 90 minus of A, this is again nothing but the side which is opposite to the angle C, which is AB divided by the side adjacent to C, which is nothing but BC. Now further, I'm just talking about the cosec of 90 minus of A. Again, this would be the reciprocal of this particular angle. This is 90 degree, 90 degree and 90 degree. So this would be nothing but is equal to AC divided by AB. Now simultaneously, if I'm just taking the reciprocal of the cos, that is secant 90 minus of A, and again this would be nothing but AC divided by BC. And similarly, if I'm just taking the reciprocal of the tangent, which would be nothing but cotangent, so this would be cot of 90 minus of A, which is nothing but is equal to BC divided by AB. Now we can see a very important fact over here. Let's just compare these trigonometric ratios and these trigonometric ratios. So first of all, if I'm just talking about sin 90 minus A, as you can see over here, sin 90 minus of A is actually nothing but is equal to AB by AC. You can see over here, sin 90 minus of A is actually AB by AC. Now let's just look out for the ratio AB by AC over here. Where is AB by AC? Let's just look at AB by AC. As you can see, AB by AC is nothing but this particular ratio over here. So what can we conclude? We can conclude that sin 90 minus A is actually coming out to be equal to cos of A. Why so? Because the ratios are same. Since sin 90 minus A is nothing but a ratio AB by AC, and over here we have cos of A, which is nothing but AB by AC again. So it means that sin 90 minus A is actually coming out to be equal to cos of A. So let us suppose if I'll write it over here, that for the very first concept, we are actually, after taking the comparison in between these two particular ratios, we are getting the result that sin 90 minus A is actually nothing but coming out to be is equal to cos of A. Now further, if I'm talking about cos of 90 minus A, as you can see over here, the ratio is BC by AC. Let's just look out for the ratio BC by AC over here. Where is BC by AC? So as you can see, BC by AC is nothing but sine of A. You can see all by yourself that BC by AC is here, and this is nothing but is equal to sine of A. It means that the cos of 90 minus of A is actually is equal to sine of A. So what we can write over here, we can write that cos of 90 minus of A is actually coming out to be is equal to sine of A, after taking a comparison in between these two ratios. So in the simultaneous manner, you can also find out that these ratios are coming equal to be these ratios. In what manner? Let us suppose if I'll write all the ratios one by one. So first of all, the very first concept that we are getting over here is nothing but sine 90 minus A is actually is equal to cos A. Like I just wrote here that sine 90 minus of A is nothing but is equal to cos A. So this is my very first concept. The second is nothing but cos 90 minus A is nothing but is equal to sine of A. You can see all by yourself that these ratios are coming equal to each other. Now the next concept, if I'll say that, or the next complementary angles, if we can see, then we can find out that tan 90 minus A. As you can see, tan 90 minus A is nothing but AB by BC. Now let's just look at AB by BC over here. You can see AB by BC is nothing but cot of A. So hence tan 90 minus A is nothing but is equal to cot A. Further, you can see that cot 90 minus of A is actually coming out is equal to tan of A. You can compare all by yourself. You can see this particular fact from all these ratios that they are coming equal to each other, and in the simultaneous manner, secant 90 minus of A is actually coming out to be equal to cosecant of A, and cosecant 90 minus of A is equal to nothing but secant of A. So these these are nothing but called as the trigonometric ratios of the complementary angles. So these are the really very important concepts. Always remember that sine 90 minus of A is nothing but cos of A, cos 90 minus of A is nothing but is equal to sine of A, tan 90 minus of A is nothing but is equal to cot of A, cot 90 minus of A is nothing but is equal to tan of A, secant is nothing but is equal to cosecant, and cosecant is nothing but is equal to secant. And very important concept over here that for all the values of the angle A always lies in between 0 degree and 90 degree. So always remember that the angle A should always lie in between 0 degree and 90 degree. And most importantly, in order to remember it, we can remember it in a particular fact that as you can see, sine after applying 90 minus A angle means the complementary angle on the sine is actually getting converted into cos. As you can see, sine is converting into cos, sine is converting into cos. And in the similar manner, if we are applying 90 minus A on cos, then cos is converting into sine. So it means that they are nothing but a vice versa condition. Whenever we will apply 90 minus A on sine, it will be cos of A. When we will apply 90 minus A on cos, then it will be nothing but sine of A. So you can remember from this particular fact that whenever we will apply 90 minus of A on sine, it will be cos. When we will apply 90 minus A on cos, it will be sine. And in the simultaneous manner, tan would get converted into cot and cot will get converted into tan. You can see from this fact, tan 90 minus A is cot A, cot 90 minus A is nothing but tan A. Now next is secant. Secant is converting into cosecant and cosecant is converting into secant. So this is the way you can remember. So let us suppose if I'll write it over here, PTR means the point to remember. So this is the way you can remember these complementary angles, that sine is getting converted into cos, cos and sine, and so goes on. And the most important fact that the angle A over here, they are lying in between 0 degree and 90 degree. So always remember these are nothing but called as the complementary angles.